Now let's get started. All right, so open that link and follow along in just a moment. In question number one, they want us to change this into a matrix. So this part right here is going to go into the coefficient matrix, or the first part. These numbers will go over here. So this is how you do it, right? So this is, remember, they have to be in order. So this is all the X's right here. Notice how row 3 does not have an X. So you're going to put a 0 in that spot. Here's another 0 for the Y. Here's a 0. Okay. So this would be 8 for X, 3 for X, 0 for Y, or for the third row. Okay, so the number where numbers are coming from here, right? This 8, this 3, this 0. This 2, this 0, this 2. So 2, 0, 2, -3, 7, -4, and 7. Does everyone see where these numbers came from? Because you need to be able to set it up if you're going to use your solver or your calculators. All right, so no questions on the first one. All right, number 2. Here we're going to have to distribute first. So multiply the 5 here and here. So that'll give us, that would become, right? 5y. Well, let's do this on paper. This is a lot more steps than I thought. One sec. So there's equation 1 and 2. So we gotta set it up like the last problem we just did, where you have the x's first and then the y and then the constants on the other side. So for the first one, I'm gonna multiply everything by 5. That'll be 5y minus 5x equals 5x plus 6. Now I'm gonna get these in order. I didn't change this guy. I'm gonna add this over here. But this is still number 1. So I added the 3x over there. Or added it to both sides, really. So equation 2 is ready to go. Notice how we got x and then y equals to some number. So this, I need to get the x in order first, and I need to get this x on that side and combine like terms, and then we're good. So I'm going to subtract this over there. So put this one first. Subtract the 5x, so that would be this. 5y is hanging up. Okay, now combine the like terms and we're ready to go. Any questions about the algebra? Kind of skip some minor steps, but if you don't see it, that's okay. Okay, so what the homework wants is to get it in this form, or set it up first, and then get it into matrix form. So matrix form would be -10, 5, 3, 4, 6, 7. There we go. So the -10, 5, and 6, -10, 5, and 6, 3, 4, 7, 3, 4, 7. Does everyone see where these numbers are coming from? I remember this is the column of the x variables, so this is where the coefficients of the variables go. So -10 is right there, 3 is right there. So this column is the x's, 5 and 4 is the column for the y's, so 5 and 4. And then the equal to part is on the right-hand side, 6, 7. So on the homework, what they want you to do is fill in those boxes. So basically put it into matrix form. So we have -10, 5, 6, 3, 4, 7. Any questions on this number 2, I think it is. All right, so here's their pretty example. Do all the algebra to magically get it to here. Once you're there, put the x's down the first column and the y's down the second column, and then the numbers here. And then that's it. I showed more steps over here, right? But basically do the algebra to get all your x's and y's on the left-hand side. Distribute anything you need to do, combine things that you gotta combine, and then get to here. So what we did, distribute the 5 times y, 5 times -x, gave us these two. And then I moved this 5x over there. I moved this 3x over there. And then combined some terms and we were good. So just do your basic algebra to get it in that form. Yeah, so all the x's first and then the y's and then equal to the numbers. And that's what goes here, the numbers. So essentially this is, if you change it back to equation form, right, this is -10x plus 5y equal to 6, 3x plus 4y equal to 7. That's what this means. All right, look at another one. So eventually we're going to want to solve them, solve the matrix. But first, let's talk about going back and forth. Check this guy out. This is what I was saying before, right? This is the X column. This is the Y column. So change it into equation form. So they're going to give you a matrix. You want you to change it back to equations. So negative 7x, negative 7y, or plus 7y equal to this part. Negative 7x plus 5y equals to the 4. So the goal of the beginning of this section is, can you change it from equation form to matrix form? And can you change it back? Okay, here is they're doing a row operation. So remember, this is row 2 right here. This is row 1. So what they're doing is saying, you know what, change row 2 by multiplying by 1/3 to get a new row 2. So you would divide everything here by 3 or multiply by 1/3, which is the same. So 0 times 1/3 gives you a 0. 6 times 1/3 is a 2. 9 times 1/3 is a 3. So they're multiplying the entire row by 1/3 to get this. Does that make sense? Do you see what they're doing or what they mean by row third times row 1/3 times row 2 equals a new row 2? So we're basically replacing, you can think of it two ways. We're replacing this row with this new row here, 1/3 times row 2. Or you can think of it as multiplying every entry in the second row by 1/3, giving you a new row 2 here. That's all they're doing. Okay, let's move on to solving. So here, I don't want you to do all these steps. No, I don't like that question. No worries, Jonathan. Oh, send the video and remind later. Let's see here. Okay, so let's move on to 10.3. I think the last one. Wait, is there a two? Okay, here we go. So it's 10.2. So here they kind of just want you to be able to, what's the word? Interpret the matrix. So if you see this matrix, they want you to be able to tell by looking at it, is it, does it have a solution? Does it have infinitely many or no solution? Because remember, these are representing equations, right? So there's still those ideas. So if we change this back into equations, you get 1x plus 9y, right? Remember, this is the x column, this is the y column, and then the right-hand side is equal to that number. That's 691. I didn't write the one because it's invisible. Now here there's just zero, so there's no variables. It's just zero equal to a number. So notice we have a false statement, right? Zero is not equal to four. So whenever you see a row of zeros equal to some number, there is no solution. And you can see it when you change it to equations, right? It's an ugly Y. Any question on this? Do you see why there's no solution? Okay, check out this one. Here we have a row of zeros. So whenever you have an entire row of zeros, this is x plus 6y equals 7, 0 equals 0. This is the x and y column. So when this happens, you get a true statement, meaning infinite solutions. So there's no unique solution, it's just infinite. Okay, whenever this happens. Now this one, this is the X column, Y and Z. This is basically X equals -3. Y equals 8. Z equals 0. So this is one specific solution here. Those are the three scenarios. So no solution, infinite solutions, and unique. So it can be a little weird to write this when you have the infinite case. We'll talk about that in just a second. But remember we said if there's so basically if there's a ones along the diagonal, because this is the first one is x equal to 1, y equal to 8, z equal to -6. So that's where this comes from. This is the x, y, z. So on this one, we have infinite solutions. So whenever that happens and they want you to write the solution, basically you gotta change them to equations. So remember this first one is um, x plus, x minus z equal to 2. The next one is y equal to, no, I should actually, no. Y plus z equal to 5. When you have a row of zeros, you say, well, it's just z is whatever, right? Just z. So if you solve for x and y in terms of z, you're going to get these two. So move the z over and you get x equal to 2 plus z. Subtract the z over and you get y equals 5 minus z. And then the last one, you just call it z. So that's where this comes from. That only happens when you have the infinite case. Do you see how they got this answer here? So step one is change this into equations. That's where we got this from. Once you have that, solve for x on the first equation, solve for y on the second equation. That'll give you the solution. 'Cause this is basically saying x equals this first term, y equals the second part, z equals the third part. And that's coming from here. So because this is the infinite case and there's a row of zeros, then you can only solve in terms of one of the variables. That's why the answers aren't specific numbers, it's just 2 plus z, 5 minus z. So it's an infinite case because z can be anything, which would change all these. All right, let's move on to another one. So here's another example. On this one, you can see the answer real quick, right? So row of ones or diagonal ones. So x is equal to 8. Y is equal to 6. Z is equal to -4. That's where this answer comes from. Is part A clear? Okay, so on this one, notice that the Z column has no solution, so it's going to be infinite case, just like the other example. So change these two equations first. So 1x plus 4z. Y plus 3z. And if there's a row of zeros, just put z equals z in that location there. Okay. So now solve for x on equation 1. So just move this guy over. Just subtract it over to this side. Subtract this one over there. And then you're going to get this solution. So equation 1 is going to be x equals 4 minus 4z. Right, subtract the 4z on both sides, you're going to get this. Y equals 3 minus 3z. And that's where the x coordinate comes from here. The y coordinate is from here. And z is just z, because it can be anything. Because this is the infinite case. Are there any questions on this guy? Okay. So in this one, I want you to use the matrix calculator that I put in the chat here. Let me copy it again. Just in case. All right. So change this into a matrix first. So here we go. Matrix form is 2 for this first coefficient, 1 for this one, 4 for this guy, and 2 for that one. And then 6 and 2 is the augmented side. Okay, so now I'm not going to make you solve these by hand because it's just a lot of work, and this is the last couple of sections in this book, so I just want you to get the answers and move on. Okay. So our matrix was something. Let me write it right there. 2, 4. Okay. So remember, the dimensions of this. Oh, I guess it doesn't matter, but just so you know, the dimensions are always row by column. One of the old books used to say, remember RC Cola, row column. So we have 2 rows and 3 columns. Now, we don't have to worry about it here because we can just click the plus and minus button here. Oops, I messed up. No, there we go. So we have 2 rows and 3 columns. So here we go. So put in 2 to your matrix calculator. Let's have it solve it for you. 2, 4, 6, 1, 2, 2. 2, 4, 6, 1, 2, 2. So now once you have it in there, press enter and do RREF on A. So matrix A is what we just input. So press the RREF button and then choose A because that's what we're doing operations on that, and hit enter. So notice we have a row of zeros equal to a number. Do you remember what that means? Which case is this? Yeah, so whenever you get a zeros and then a number, that's no solution. You get a row of zeros, we get that weird scenario where we have infinite solutions and we get that Z thing or whatever. But anyway, so now that we know that there's no solution, just click none. Now they did a bunch of row operations, so this is kind of annoying, but we use the calculator to jump straight to here. And when you change it into equations again, you can see 0 is not equal to 2. That makes no sense. So no solution. Okay, so use the solver to get this. Is there any questions on this problem? Now this one is even more work, so let's just punch this into our calculator. Let's switch to calculator. Okay, new matrix. This is, let me change it into matrix form for you right here. It'd be 1, -2, 1, -3, 7, -5, 15, -38, 31, -8, 20, 13. Okay, so once you change the matrix form, remember we have 3 rows and 4 columns, right? RC. So we got 3 rows, 4 columns. So just put it in here. It's a 31, by the way. Good. Enter. So now I have matrix A in the system here. Row reduce echelon form is what RREF means. That means you get ones in the main diagonal if they exist. All right, so notice we got that same scenario as last time, right? It just so happens we get 0 equal to a number. There's no solution. If you had ones all the way down and then some numbers here, then you would have a unique solution. If you had a row of zeros, then we would have infinite solutions. So let's look at the question. So they change it to matrix form, and then they solve it using row operations by hand, but we jump straight to here thanks to the calculator. And then, excuse me, they find out there's no solution because of this. Just so happens. Anyway, that's pretty much it for 10-2. Just understand the different cases like we've been talking about over and over again. Solve the matrices with your calculator. You can solve it with the graphing calculator or you can solve it with Desmos. Either way. You guys have any questions? We're gonna stop lecture here.